Hi students, good morning to all. Grade 11 Mathematics. Today continues of chapter number 13, limits and derivatives. Already exercise number 1 is completed through online classes. Today continues of limits of trigonometric function. Take your NCERT book, page number 298. Theorem number 3. Limits of trigonometric function, theorem number 3. Let's f and g be a two real valued function. Let f and g be a two real valued function with the same domain such that f of x is less than or equal to g of x for all x in the domain of definition for some a if both limit extends to a f of x and limit extends to a g of x are exist. Then limit extends to a f of x is less than or equal to limit extends to a g of x. Limit extends to a f of x is less than or equal to limit extends to a g of x. Listen students, f and g be a real valued function. Okay, f and g be a two real valued functions and a domain and same domain. Okay, if f of x is less than or equal to g of x, f of x is less than or equal to g of x, if a is any number, or any point on this domain, then limit extends to a f of x and limit extends to a g of x or exist. So both function f of x and g of x are all exist where limit extends to a. That means limit value exists at x equal to a. Okay, right. Then here f of x is less than or equal to g of x. F of x is less than or equal to g of x. Limit always exists. Then the result limit extends to a. F of x is also less than or equal to limit extends to a g of x. Okay. Then it's graph x axis, y axis. This is f of x, y equal to f of x curve. This is y equal to g of x curve. At x equal to a. At x equal to a. A is any points on this domain. Okay. So here at x equal to a, these two curve f of x and g of x are always equal or less than or equal to less than. So f of x and g of compare with the two function f of x and g of x limit value at x tends to a. F of x and g of x value is at x equal to a, at x equal to a, this both value is same, equal. That means limit extends to a f of x is less than or equal to limit extends to a g of x. So they equal are illa appadina g of x greater are. So this is the theorem number 3. Okay, right. Next theorem number 4, sandwich theorem. Next theorem number 4, sandwich theorem. Name of this theorem is sandwich theorem. Let f, g and h be a real value function such that f of x is less than or equal to g of x is less than or equal to h of x for all x in the common domain of definition for some real numbers a. If limit extends to a, g of x is less than or f of x is less than or equal to limit extends to a, g of x is less than or equal to limit extends to a, h of x. Okay, right. Listen. Oh, last theorem, two functions. Have to take two functions f and g. Here three functions f, g and h. Be a three real valued function. Three real valued function. Okay, right. And if f of x is less than or equal to g of x is less than or equal to h of x. F of x is less than or equal to g of x is less than or equal to h of x. And a be any number. A is any point or number on this common domain. So three real valued function in common domain. That means same domain and three function. Okay, right. If limit values exist, that means limit extends to a f of x and limit extends to a g of x and limit extends to a h of x or all exist. Then the theorem is f of x is less than or equal to g of x is less than or equal to h of x if limit value exists for individual f of x function, g of x function, h of x function at x equal to a. That means x tends to a, limit values exist. Then the result, the theorem is limit x tends to a f of x is less than or equal to limit x tends to a g of x is less than or equal to limit x tends to a h of x. Limit x tends to a f of x is less than or equal limit x tends to a g of x is less than or equal to limit x tends to a h of x. And its graph x axis, y axis. So draw this graph f of x, g of x and h of x. First f of x, next g of x, next h of x. At x equal to a, the three functions at x equal to a, intersection of three curves f of x, this is y equal to f of x, y equal to g of x and y equal to h of x. So compare these three functions, f of x is less than or equal to g of x and g of x less than or equal to h of x. This is a sandwich theorem. That means a sandwich means g of x is in between f of x and h of x. So the function g of x is placed in between f of x and h of x. You know the sandwich variety, pizza sandwich. Sandwich mean middle. Sandwich nam theriyum. Sandwich இவங்க என்ன சொல்லுவோம், ரெண்டு பன் இருக்கும், அது மிடில் நம்ம வெஜிடபிள்ஸோ இல்லை வேறு ஏதாவது வச்சுருப்பாங்க, அதுக்கு நேம் தான் சாண்ட்விச் சொல்லிடுறோம். சாண்ட்விச் சாப்பிட்டுருப்போம்ல, அதே சேம் மீனிங் தான் இங்கே. டூ ஃபங்க்ஷன்ஸ் எஃப் ஆஃப் எக்ஸ் ஹெச் ஆஃப் எக்ஸ்க்கு இடையில் மிடில் ஜி ஆஃப் எக்ஸ்ன்ற ஃபங்க்ஷன் இருக்கிறதுனால திஸ் ஃபங்க்ஷன், திஸ் தியரம், இஸ் நேம் இஸ் சாண்ட்விச். ஓகே, ஸோ திஸ் இஸ் எ சாண்ட்விச் தியரம். ஓகே, ரைட். Listen. Next one theorem, cos x is less than sin x by x is less than 1 for 0 less than modulus x is less than pi by 2. Proof. We know that sin of minus x equal minus sin x and cos of minus x equal cos x. Then the inequality 0 is less than x is less than pi by 2. Okay, listen students. Let us consider this is a circle. O is the center of the circle. O is the center of circle. And OA, this is the radius of circle. OA is a radius of circle. PB any points. Draw the line AB is perpendicular to OA. Join O and B. O and B. This point is considered as C. O, A, B, C. Intersect of OB and this circle. This point is C. So join C and A. And also draw C, D. This point is C, D. CD is always perpendicular to OE. CD is always perpendicular to OE. So let's say take a circle with center O. Draw a circle with center O. Okay, right. And OA, here OA and OC. OA and OC is radii of circle. Radii of the circle. So that the triangle OAB. Here AB and CD. Draw AB and CD. A, B and CD is perpendicular to OE. Okay, so here the line CD and AB is perpendicular to OE, right? Let's say let us consider a triangle OAB. Consider a triangle OAB, and also let's say angle AOC. This is angle AOC is considered as X. So angle AOC is equal to X radian. Let us consider angle AOC is equal to X radian. Okay, right. Listen students, the area of the triangle OAC, area of triangle OAC is less than area of triangle OAC is less than or area of OAC. Area of that is area of sector. Area of sector OAC. This is OAC. Listen students, this is triangle OAC. This one is triangle OAC. So first find area of triangle OAC. Next is less than area of sector. That means OAC. Sector means arc length AC. AC. So compare this to area OAC plus this arc length, this area is always greater than. So compare this to area OAC. Area of triangle OAC is less than area of arc sector OAC is greater. So compared to these two values, area of triangle OAC is less than area of sector OAC. Is always less than. Is less than. Third one, area of triangle OAB, whole triangle. So area of triangle OAB, area of triangle OAB. This is considered as equation number 1. Equation number 1. Listen students, let's take a circle over the center. OA and OC is radii of this circle. Draw AB is perpendicular to OA and also CD is perpendicular to OE. Join these 2 points C and A. Have that triangle OAB and another one triangle OAC. And also OAC sector. So compare these three values. Area of this triangle OAC is less than area of a sector. Sector means this one, this arc. Area of this sector OAC. This is a triangle OAC. And area of sector. This is area of sector OAC. Okay, so compare these two area, this one is greater than. So that means area of triangle OAC is less than area of sector OAC. And also compare area of triangle OAB. OAB. This is OAC and this one is sector, this one is OAB. So compare these three area. Very small OAC, area of triangle OAC is very, very small. Compare this to area of sector OAC and area of triangle OAB. So area of triangle OAC is less than area of sector OAC is less than area of triangle OAB. This is equation number 1. Let us consider this number equation number 1. Right. So you know that the area of triangle formula of into base into height altitude. Listen, first substitute this value. Area of triangle OAC is equal to of 1 by 2 into base of this triangle OAC. OAC. This is altitude. Here altitude. Let's consider altitude is CD is altitude. So base into heights. Base into heights. So base is OA. So OA into heights CD. Listen students, area of triangle OAC is equal to half into base into heights 1 by 2 of BH. That is the area of triangle formula. Here base of this triangle OAC is equal to OA. OA is a base of triangle OAC. So the area of triangle OAC is equal to 1 by 2 into base OA into height CD. Okay, so is less than area of sector OAC. Area of sector OAC. You know that the formula area of sector formula theta by 360, that means 2 pi into pi r square. Theta divided by 2 pi into pi r square. So this is the area of the sector formula. Area of the sector formula. Listen, is less than area of triangle OAB. Area of triangle OAB means base OA, height AB. So half into OA into AB. So listen, 1 by 2 of OA into CD is less than. Theta is considered as here. Theta is angle AOC X. That means X divided by 2 pi into R square. R square R is a radius of this circle. Here radius of the circle is OA and OC is also radius. So let us consider radius as OA. So OA square is less than 1 by 2 into OA into AB. So here common value OA cancel. So divided by OA on both sides. So remaining 1 by 2. So 2 is also common. So 1 by 2 is cancelled. So remaining CD is less than X, pi by cancel, X into OA is less than AB. Is less than AB. This is equation number 2. Let us consider this in equation number 2. Okay, listen, find CD and AB. Let us consider a triangle. In a triangle ODC, that means ODC, CD is perpendicular to this triangle. So COD is a right angle triangle. So in a triangle COD, sin x is equal to, listen students, sin x equal to opposite side by hypotenuse. So here opposite side of a triangle COD is equal to CD. So CD divided by opposite side, that is CD divided by hypotenuse, that means OC. So sin x is equal to CD divided by OC. Sin x is equal to CD opposite side by hypotenuse OC. Okay, right. You know that the radius of a circle is OA is also equal to OC. So let us consider OC equal to OA, which implies OA sin x. OC is considered as OA, so OA into sin x, OA sin x equal to CD. So CD is equal to OA sin x. Since OC is equal to OA, since OC equal to OA, right? So CD is equal to OA sin x. CD equal to OA sin x. And listen. Next, in a triangle OAB. OAB. Listen students, in a triangle OAB. Here OAB is a right angle triangle. So tan x is equal to, this is trigonometric ratio, tan x is equal to opposite side by hypotenuse, sorry, adjacent side. Here opposite side of a triangle OAB is, opposite side is AB by adjacent side is OA. So therefore AB is equal to OA tan x. OA tan x. Listen students, CD is equal to OA sin x and AB equal to OA tan x. Okay, right. OA tan x. Right. So substitute this value in equation number 2. Equation number 2 implies CD is less than x into OA. CD is equal to OA sin x. So OA sin x. OA sin x is less than x into OA. X into OA is less than AB. Listen, here AB is equal to OA tan x. OA tan x. So OA tan x. So OA cancel. So listen, sin x is less than x is less than tan x. Sin x is less than x is less than tan x. In a first quadrant, that means 0 less than x is less than pi by d. In the first quadrant, sin x value is positive. So divided by sin x on both sides. Divided by sin x on both sides. We have the answer. Sin x divided by sin x is 1. Sin x divided by sin x is 1 is less than x divided by sin x. X divided by sin x is less than tan x by sin x. You know that tan x is equal to sin x by cos x. So tan x is equal to sin x by cos x. Into divided by sin x means 1 by sin x. So sin x cancel. Remaining 1 by cos x. So tan x divided by sin x is equal to 1 by cos x. 1 by cos x. Okay. So take reciprocal on both sides. Take reciprocals. You know, take reciprocal, the inequality changes. So 1 by cos x is written as cos x. Less than of x by sin x is sin x by cos x. Sin x by x is less than, reciprocal of 1 is 1. This is a result. Okay. So listen students, cos x is less than sin x by x is less than 1. Take reciprocal on both sides. So reciprocal edutha appadina inequality change less than greater number greater than less than number. So here 1 by cos x change பண்ணும்போது இங்க greater than change ஆகும். So greater than நான் left side கொண்டு வந்துட்டேன். So cos x of less than அப்படியே reverse எழுதிருக்கு. அதான் இங்க inequality change cos x 1 by cos x is written cos x is less than x by sin x is written sin x by x is less than 1. Okay, right. This is a required result, hence proved. So therefore cos x is less than sin x by x is less than 1. This is a result. Listen, next proportion 5, following are two important lines. That means first result, limit x tends to 0, sin x by x equal to 1. Limit x tends to 0, sin x by x equal to 1. Listen, so listen students, You know that limit x tends to 0, sin x by x is equal to 1. Here is a proof and the proof. You know that cos x is less than sin x by x is less than 1. And the first question, x is belongs to 0 comma pi by 2. That means 0 is less than, x is less than pi by 2. If x is tends to 0, limit x tends to 0, take limits on both sides. Limit x tends to 0, cos x is less than limit x tends to 0, sin x by x is less than limit x tends to 0, 1. So limit x tends to 0, cos x, that means cos 0. So cos 0 value, you know the cos 0 value. So cos 0 is less than sin x by x, limit x tends to 0, sin x by x. Suppose 0 substitute sin 0, 0, 0 by 0, infinite. So substitute is less than limit x tends to 0, 1. 1 is a constant function, that means 1. So cos 0 value is 1. So 1 is less than limit x tends to 0, sin x by x is less than 1. So compare these two values. So the value of limit x tends to 0, sin x by x is in between 1 to 1. That means almost this value limit x tends to 0, sin x by x is equal to 1. Therefore, limit x tends to 0, sin x by x is equal to 1 from this result. Okay, very important results. Okay, so limit x tends to 0, sin x by x is equal to 1. Already formula is sums work out pannirpom, but idukana proof vadum. Okay, so cos x is less than sin x by x is less than 1. Use this circle format. Okay, therefore which implies limit x tends to 0, sin x by x equal to 1. And another one formula, limit x tends to 0, 1 minus cos x by x equal to 0. So already 1 minus limit x tends to 0, 1 minus cos x by x equal to 0, proof kodutachu. Okay, right. Next, another one, theorem number 2. For any positive integer n, limit x tends to a, x power n minus a power n by x minus a equal to n into a power n minus 1. n into a power n minus 1. Okay, the theorem already live class proof panniyaachu. Very simple theorem, but the result very important. Limit x tends to a, listen students, limit x tends to a, x power n minus a power n divided by x minus a equal to n into a power n minus 1. This is theorem number 1. Theorem number 1. Next, next result, limit x tends to 0, sin x by x equal to 1. Another one result, limit x tends to 0, 1 minus cos x by x is equal to 0. So these three results are very important. So study well the three formulas. Okay, right. Next, second result proof. Second one results, limit x tends to 0, 1 minus cos x by x. Already live class proof pannirpom, last agenda konjam proof pannirpom. Listen once more, limit x tends to 0, 1 minus cos x by x. Limit x tends to 0, 1 minus cos x by x. We know that the trigonometric formula 2 sin squared x is equal to 1 minus cos 2x. If 2 sin squared x by 2 is equal to 1 minus cos x. 1 minus cos x. So we know that 1 minus cos x formula is equal to 2 sin squared x by 2. 2 sin squared x by 2. Listen, here the limit x tends to 0, 1 minus cos x by x. Apply this value. Limit x tends to 0, 1 minus cos x by x. Here if x equal to 0, this value 1 minus cos 0, 1, 1 minus 1 is 0, 0 by 0 indeterminate form. This form is indeterminate form. So 0 by 0 form is indeterminate form. So x equal to 0 is apply panna mudiyadhu. So listen, first change this form, it limit x tends to 0. 1 minus cos x equal to, use this formula, 2 sin square x by 2. So 2 sin square x by 2 divided by x. Divided by x. You know one result, limit x tends to 0, and we know that limit x tends to 0 plus previous theorem, sin x by x is equal to 1. So change its format. So here 2 sin square x by 2 by x is equal to limit x tends to 0 sin x by 2 into sin x by 2, that is sin square x by 2, divided by, here 2 is written in the denominator form, is x by 2. Okay, the numerator 2, denominator change numerator, written in the form x by 2. Okay, so sin x by 2 by x by 2 into sin x by 2 into sin x by 2. So listen, so limit x tends to 0, limit x tends to 0, sin x by 2, sin x by 2 by x by 2 into product rule, algebraic formula, limit x tends to 0, sin x by 2, sin x by 2. This is in the form sin x by x form, change this form. So substitute this value, let y is equal to x by 2, let y is equal to x by 2, then y is tends to, it's also same, y is tends to x, if x equal to 0, 0 by 2 is 0, so y is tends to 0 as x tends to 0. So substitute this value, limit x is converting x by 2 is equal to y, then y is equal, if x tends to 0, then y value, substitute this value, 0 by 2 is 0, so y is tends to 0, y is tends to 0, sin x by 2 is written, sin of x by 2 is, use this value, y, divided by x by 2 is y, so sin y by y form, into limit x tends to 0, sin x by 2, so substitute this value, sin 0, x equal to 0, that means 0 by 2, 0. Listen, you know this formula, limit x tends to 0, sin x by x equal to 1. So limit y tends to 0, sin y by y is equal to 1 into sin 0 value 0, 1 into 0, 0. So therefore, the limit x tends to 0, 1 minus cos x by x value is equal to 0. This is correct value. Limit x tends to 0, 1 minus cos x by x is equal to 0. This is the second result. Okay, right. Okay, listen students. Still now, limits concept. First exercise is completed. Limit of algebraic expressions and the limits of trigonometric functions. And the theorem number 1, 2, 3. And the results, limit x tends to 0, sin x by x equal to 1, and the limit x tends to 0, 1 minus cos x by x equal to 0, and its proof. And exercise number 13.1 plus example 1 to example 4 is already completed. Next, derivatives. Next, derivatives. Exercise number 13.2 is a derivatives. This derivatives is very, very important topic. And when we use this topic, okay, so we see next class, okay, bye, right.